A silent piece of metal is falling toward the moon tonight. No engine burns, no alarm sounds, and no human hand can stop it now. It glides through the dark like it has chosen this ending for itself. In a few hours, one of our own machines may carve a fresh wound into lunar dust. If space stories like this keep you up at night, subscribe and stay close. This is for people who want the real story, not just the quick headline. Because this strange countdown says more about us than it does about the moon. The headline sounds simple, but the truth hiding inside it is not simple at all. A SpaceX rocket is about to hit the moon, but not the whole rocket, and not by design. The object is an upper stage, the part that keeps going after the first stage has done the heavy lifting. It is dead hardware now, but dead hardware in space can still travel for a very long time. Most people think a launch ends when the camera cuts away and the booster lands. That is the clean version, the version with fire, cheering, and a perfect splash of light on the pad. The messy version starts after success, when pieces separate, drift apart, and keep moving through space with no audience left watching. Sometimes those forgotten pieces vanish into harmless emptiness, and sometimes they come back into the story in a way nobody expects. This story begins with a Falcon 9 launch on January 15, 2025. SpaceX sent 2 lunar missions outward on that flight, Blue Ghost and Hakuto-R Mission 2. The rocket did what it was built to do, pushing those spacecraft away from Earth and onto paths that could lead to the moon. The launch looked like another clean step in the new rush to send machines and soon people back to our nearest world. Blue Ghost later landed on the moon on March 2, 2025. Hakuto-R took a longer route to save fuel and tried to land on June 5, 2025. That attempt failed, and contact was lost shortly before touchdown, turning hope into another hard lesson about how cruel lunar landings can be. But even as people focused on those missions, something else from the same launch kept drifting almost unnoticed above them. That something was the Falcon 9 upper stage. It had done its job and separated, leaving behind a long metal body of tanks, pipes, and one powerful engine. It was not built to come home like the reusable first stage, and it was not carrying a mission anymore. It was just there, a 5-story shell left alone in the strange space between Earth and the moon. That region sounds empty, but it is not empty in any simple way. Earth pulls there, the moon pulls there, and even sunlight can slowly push large light objects over time. A dead stage drifting through that zone is not parked like a car in a lot. It is more like a leaf on a restless pond, always moving, always being nudged by forces too small to feel and too real to ignore. That is where the first expectation crashes into reality. People expect a used rocket stage to leave the spotlight and stay on some quiet path for years. What actually happens is that the path can bend, stretch, and change until a harmless leftover becomes the center of a new mystery. That matters because the more often we travel beyond Earth, the more often we will leave behind objects still writing their own stories. The object now heading for the moon is not tiny. It is roughly the height of a 5-story building and has a mass near 4,900 kilograms. That is about 10,800 pounds, which means this is not a bolt, a panel, or some loose scrap. It is a giant empty machine, and when a giant empty machine slams into the moon, scientists pay attention. Did you expect old rockets to stay quiet once their missions ended? Tell me in the comments, and if you want more real space mysteries, like this video and subscribe now. Because the next part is where a forgotten object becomes a tracked countdown. The man who has been following this case closely is astronomer Bill Gray. He is known for tracking distant objects, including debris that normal systems often do not follow very well. That may sound like a small job, but in deep space it matters more than most people realize. When an object moves far beyond low Earth orbit, the number of eyes watching it drops fast. People often assume agencies track every important object in space all the time. That sounds reasonable because we can land probes, send robots to Mars, and map distant worlds in stunning detail. But deep space junk sits in a weird middle ground, where it is too far for some common systems and too unimportant for constant attention. That gap is exactly why a dead rocket stage can drift for months before the world suddenly remembers it exists. Near Earth, radar does a lot of the hard work. Radar is excellent for finding and following debris in lower orbits close to our planet, but the moon is about 400 times farther away than many low-orbit targets, and signals get much weaker with distance. In simple terms, the farther out the junk goes, the easier it becomes for it to slip into the dark between our tools. That is why telescopes matter here. Asteroid surveys, skilled amateurs, and careful observers looking for faint moving dots often become the people who notice what larger systems miss. A drifting stage is not glowing like a lighthouse, and it does not send back a neat signal saying where it plans to go. It just reflects sunlight, tumbles, fades, brightens, and slowly gives away its path to anyone patient enough to keep measuring it. At first, experts expected this upper stage to remain on a long, high path around Earth. Some leftover stages fall back and burn in our atmosphere. Some are pushed away into orbits around the Sun, far from both Earth and the Moon. This one did neither, and that difference is the reason we are talking about it now. Instead, the orbit slowly lined up with a future encounter. The stage had been circling Earth for more than a year, but not in a clean, simple loop. Over time, gravity and sunlight kept shaping its motion until one result became clear. It was not just passing through the Earth-Moon neighborhood anymore, it was heading toward a collision with the Moon itself. The predicted impact speed is about 2.43 kilometers per second. That is around 1.5 miles every second, or roughly 5,400 miles per hour. Big numbers can feel distant, so picture this instead. In 1 second, it could cross more than 20 football fields. There is no air to slow it down, no parachute, and no engine firing to pull it away. Here is where many people imagine a bright, fiery crash visible to everyone. That makes sense because on Earth, fast objects burn, smoke, and scream through the sky. But the Moon has no air, so there is no long, glowing trail, no thunder, and no roar for human ears. There will only be a sudden impact, a violent blast into dry ground, and whatever dust or light that strike manages to create. Could you spot a moon impact if it happened while you were already staring at the right place? If you think you would try, leave a comment, hit like, and subscribe for the next turn. Because what scientists hope to see is even stranger than the collision itself. The impact is expected near a crater called Einstein, close to the Moon's edge as seen from Earth. That location matters because it raises one exciting possibility. Even if the impact flash is weak, material blasted upward might rise high enough to peak above the lunar edge. If that happens, observers on Earth could briefly see ejecta, meaning dust and broken rock thrown into space by the hit. No one can promise that plume will be visible. That is part of the tension in this story. A natural meteor can strike the Moon much faster than this rocket stage, and faster impacts often make brighter flashes. So the event may be important scientifically, even if it looks quiet from Earth and leaves backyard telescopes staring at nothing obvious. Scientists can still estimate the power involved. With a mass near 4,900 kilograms and speed near 2.43 kilometers per second, the impact energy comes out to about 14.5 billion joules. That is roughly equal to about 3 tons of TNT, enough to blast a new crater into the lunar surface. It is not world-ending, not even close, but it is far beyond a small scrape or a harmless tap. Some estimates suggest the new crater could be around 17 meters across. That is about the width of a city bus laid sideways, or a small house lot. For the Moon, that is tiny compared with the giant craters we can see from Earth. For a fresh scar made by human hardware, it is large enough to matter and easy enough to study once orbiters find it. That is what makes this a rare event. The Moon is hit all the time by natural rocks, but we almost never know the exact history of the object before impact. Here, the object has a known shape, known mission, and known mass range, giving scientists a cleaner case than a random meteoroid. A machine built by humans is about to become an accidental experiment on another world. Now we need to step back to an older mystery, because it helps explain why this event feels both familiar and different. In early 2022, headlines spread around the world claiming a SpaceX rocket stage was on course to hit the Moon. That story exploded because it sounded wild, careless, and almost too perfect for the internet. But the deeper truth turned out to be more confusing and more useful. Astronomers were tracking an object called WE0913A. At first, it was linked to a Falcon 9 upper stage from the 2015 DSCOVR mission. The claim spread fast, and many people treated the case like proof that SpaceX had already started littering the Moon. Then, closer study began to poke holes in that simple version. The expected story was that the object had come from the DSCOVR launch path. What was actually found was that the numbers fit a different mission better. Bill Gray later said the stronger match was a Chinese Long March 3C upper stage from the Chang'e 5 T1 mission launched in 2014. That change may sound like a technical footnote, but it changed the whole identity of the object. So the famous 2022 SpaceX Moon crash was likely not a SpaceX crash at all. That mattered for fairness, but it mattered even more for another reason. It showed how hard it is to track objects once they move beyond the easy zones near Earth. If experts can debate the identity of a large rocket stage, then cislunar space is more poorly watched than many people imagined. The 2022 story did not end with identity confusion. That object really did hit the moon on March 4, 2022, on the far side near the crater Hertzsprung. Later, NASA's Lunar Reconnaissance Orbiter found the impact site and gave scientists a surprise. Instead of one neat crater from one incoming rocket body, the spacecraft saw a double crater. One part of that double crater was about 18 meters wide. The other was about 16 meters wide. That was unexpected because a spent rocket usually carries most of its mass near the engine end, while the rest is mostly empty tank. A single object should have made one main crater, yet the moon recorded something much stranger. Do you think space junk becomes more interesting when the moon keeps the evidence for us? Tell me below, and if you want more stories where facts change the whole picture, subscribe now. Because that double crater changed how scientists look at these impacts. The best guess is that the 2022 object had large masses at both ends. That could mean the rocket body was built in a more balanced way than expected, or that parts inside it were arranged strangely. Whatever the reason, one impact left two clear scars. The moon turned into a kind of crime scene, showing researchers that leftover hardware can reveal its hidden shape only after it crashes. That older mystery matters now because it changed what experts expect from the new SpaceX impact. Before 2022, many people would have imagined a simple one-body, one-crater result. Now they know a tumbling rocket stage can surprise them even after the flight is over. So the coming crash is not just a countdown to impact, it is a chance to test what we think we know about these hollow machines. This is the pattern you should notice all through the story. Experts expect something tidy. Clear tracking, known identity, simple structure, harmless disposal. Reality answers with uncertainty, mistaken labels, strange crater shapes, and long paths nobody planned. That gap matters because the space age is moving outward faster than the rules and habits built to manage its leftovers. And this is no longer only about science, it is about traffic. The region between Earth and the Moon is getting busier with private missions, national programs, test flights, landers, and future crew plans. Every new object launched outward is another object that must be tracked, managed, and eventually disposed of somehow. Many people assume cislunar space should be safer than low Earth orbit because there is more room. That is the second big expectation. More room should mean less danger, fewer collisions, and easier management. But more room also means weaker tracking, larger blind spots, and a greater chance that problems stay hidden until late. Think of it like a huge highway at night, with long, dark stretches and only a few cameras. Cars are spread far apart, so traffic feels light. But if one driver loses control, finding the danger quickly becomes harder, not easier. That is what deep space can be like when objects drift far from the places our best systems watch every day. This Falcon 9 stage is not hitting a base, a lander, or an astronaut. There is no direct danger to people on Earth either. So in the short term, the event is harmless in the most obvious sense. The trouble is what it says about the habits we are carrying with us into the next age of lunar exploration. After a mission ends, a leftover stage can become an afterthought. Getting rid of it neatly often costs extra fuel, planning, and money. Mission teams are focused on reaching the target, landing payloads, and meeting tight performance limits. That means the dead stage can become the part nobody loves enough to manage carefully after its work is done. That does not mean people are careless in some cartoon villain way. It means spaceflight is full of trade-offs. Every kilogram of fuel used for disposal is fuel not used for payload or safety margin during the main mission. But trade-offs have long shadows, and sometimes those shadows reach all the way to the surface of the moon. Do you think old rocket stages should be forced into safe disposal paths, even if that makes missions more expensive? Drop your answer in the comments, tap like if you think the rules should change, and subscribe, because this quiet impact may become an argument about responsibility long after the dust settles. There are alternatives, at least in some missions. A stage can sometimes be sent back toward Earth to burn up in the atmosphere. Sometimes it can be pushed into an orbit around the Sun, away from both Earth and the Moon. Sometimes a planned impact might even be acceptable if it is announced clearly and used for science instead of happening by accident. The real problem is not impact alone. The real problem is surprise. A planned event can be measured, prepared for, and folded into safety rules. An accidental event sends astronomers scrambling, pushes rumor faster than fact, and reminds everyone how much of deep space still sits outside clear oversight. This is why better tracking keeps coming up in discussions about the moon. If missions to lunar orbit and the surface keep growing, then the space around the moon becomes a place people depend on. That means losing track of large hardware becomes less acceptable with every passing year. The question is not whether more objects will go there, but whether we will build order before disorder becomes normal. There is a human side to this that makes the story hit harder. For thousands of years, the moon has looked untouched, distant, and calm. People wrote poems to it, swore promises under it, and used it to measure time long before rockets existed. Now it is also becoming a work site, a target, a map, and a place where our mistakes can leave permanent marks. That change is emotional, even if you are not usually sentimental about space. We like to imagine the moon as a clean symbol of wonder. Then a story like this arrives and reminds us that human progress always drags tools, waste, and unintended consequences behind it. The beauty stays, but innocence does not stay quite as easily. And still, this event is not only depressing, it can also teach us. Because the incoming object has a known launch history and a fairly well-understood size, scientists can compare what they predict with what the moon later shows them. If the crater shape, ejecta, or final location differ from expectations, those differences will sharpen future models. That may sound narrow, but it connects to real future missions. Understanding how impacts scatter lunar dirt can matter for landing site studies and surface operations. Learning how a large hollow body behaves on impact can improve estimates for both natural and human-made strikes. And knowing how well we predicted the site helps test the limits of current tracking in cislunar space. This is where the story shifts from what happened to what is happening right now. As the stage closes in, each new observation helps tighten the prediction. Every fresh measurement of its position turns a blurry future into a smaller target on the moon. It is like watching a mystery collapse into a fact, one data point at a time. Yet there is still something eerie about the whole scene. No pilot is aboard, no software is awake, and no final command is waiting to fire. The stage is only obeying motion, gravity, and the weak push of sunlight until those forces end in one sharp moment. For something built by advanced engineering, its final act feels almost ghostly. If you watched a telescope feed of the moon and knew this object was seconds away, would that make the moon feel different to you? Tell me in the comments. Like this video if this story got under your skin, and subscribe. Because the last part of this countdown is less about metal and more about what kind of future we want. The easiest response is to shrug. The moon already has countless craters, and one more small mark changes almost nothing on a world scarred for billions of years. That is true in a narrow sense, but history is built from patterns, and patterns start as small things people decide not to care about. One accidental impact is not a lunar disaster. It will not knock the moon off course, threaten Earth, or erase anyone's footprints. But if we keep treating cislunar debris as background noise, then background noise becomes normal. And once normal is established, real rules always arrive later and under worse pressure. Human history on Earth follows that pattern again and again. We enter new spaces, chase growth, celebrate breakthroughs, and only later ask, who cleans up the mess? That happened on oceans, rivers, roads, and in the air above our cities. Now the same question is climbing off Earth and heading toward the moon with us. What makes this feel personal is that the moon is no longer just a distant lamp in the night sky. It is becoming part of our future plans. Cargo missions are rising, landers are multiplying, and human crews are expected to follow. The path between Earth and the moon is turning from empty myth into active infrastructure. Infrastructure needs rules. It needs maps, warnings, records, and clear ideas about what happens after a mission is done. If a dead upper stage can surprise us today, imagine what 10 or 20 more missions a year could do tomorrow. The risk right now is low, but the lesson is arriving before the traffic jam does. That is why this rare event matters far beyond one crater. It is a test of whether the new lunar age will be guided only by ambition or also by discipline. Great exploration has always needed both. Dreams get us to the launch pad, but responsibility decides what kind of civilization those dreams actually build. The old romantic image of space says everything up there is pure and untouched. The modern image is more honest. Space is still beautiful, but now it also holds spent stages, failed landers, old mission hardware, and the evidence of every shortcut. The more active we become, the more the sky begins to reflect the best and worst parts of us. So yes, a SpaceX upper stage hitting the moon is a rare event. It is rare in timing, rare in visibility, and rare in how clearly we know the object's story before impact. But it is also a preview. It hints at the kind of questions that will only grow louder as more nations and companies race outward. Who is responsible for tracking every large object beyond Earth orbit? Who decides what counts as proper disposal near the moon? Who pays for cleanup when no one planned any cleanup at all? And how many close calls do humans need before rules stop feeling optional and start feeling necessary? Those questions may sound political, but they are deeply human. They touch on fairness, safety, money, pride, and the way people behave in new frontiers. The moon may seem far away, yet the choices made there will come from the same human habits we already know down here. That is why a silent drifting stage can feel like a mirror more than a machine. In the next hours, if the predictions hold, that mirror will strike ancient ground. There may be a faint flash, a hidden plume, or maybe only a crater found later by orbiting cameras. Either way, the impact will mark more than dust. It will mark a moment when the new space age quietly admitted that success and responsibility are not the same thing. Maybe that sounds harsh. After all, the same launch also carried brave engineering, careful planning, and a mission that helped push lunar exploration forward. That is true, and it should be remembered. But the strange power of this story is that one successful launch can produce both progress and a problem at the same time. Blue Ghost reached the moon. Hakuto-R tried and failed. The upper stage outlived both moments and kept its own final appointment in the dark. That is the part people may remember most because it turns a normal piece of mission hardware into the last chapter of a much bigger story. It is the story of what happens after achievement. It is the story of the parts we stop talking about once the main goal is complete. And it is the story of whether humanity can expand into space without carrying every old habit of neglect along for the ride. That is why this impact feels so much larger than the crater it may leave. As strange as it sounds, the moon is helping us by keeping the evidence. It does not wash away tracks with rain or bury scars under forests. A crater can stay sharp for a very long time, waiting for orbiters to photograph it and for scientists to study what happened. In that way, the moon records our actions with cold honesty. There is also a reason this event catches scientists who study the moon itself. Fresh impacts are like new footprints in a place where change usually comes slowly. Older craters are mixed, softened, and covered by endless tiny hits over time. A new crater gives researchers a cleaner chance to compare prediction and reality while the mark is still sharp. The moon's surface is covered in regolith, a layer of broken dust and rock made by billions of years of impacts. It looks calm from Earth, but up close it is a harsh powder mixed with jagged fragments. When a fast object slams into that surface, the ground does not behave like wet soil or soft sand. It bursts outward in a fast spray, and the pattern of that spray can teach people a lot. That matters for future missions because landers do not just touch the moon, they kick up material too. Engine exhaust can blast dust and stones across the surface during landing and takeoff. If scientists better understand how lunar dirt moves under sudden force, they can plan safer distances around bases, tools, and landing pads. An accidental crash today can still help engineers avoid avoidable trouble later. There is also the question of rotation. A dead rocket stage does not always fly straight like a thrown dart. It can tumble slowly, showing one side to the sun and then another, changing how sunlight pushes on it over time. That tumbling may sound minor, but when you are trying to predict a distant impact, tiny changes can pile up into real uncertainty. This is one reason impact predictions are given as careful windows instead of magical perfect dots. Observers can narrow the time, the speed, and the place, but there is always some room for surprise. That does not mean the science is weak. It means deep space is honest, and honest science tells you what it knows, what it suspects, and what it still cannot promise. Another detail people miss is that the moon's far side and near side create very different viewing problems. If an impact happens on the far side, Earth-based observers cannot watch the strike directly at all. If it happens near the edge, as this one is expected to, the geometry becomes more interesting. Dust rising high enough might briefly show itself, even when the ground point stays hidden from direct view. That kind of geometry turns the moon into a stage curtain. Most of the event happens behind the edge, out of sight. But if the ejecta plume rises tall enough, part of the curtain lifts for a moment and reveals that something violent happened just beyond it. That is why so many skywatchers are interested, even though the impact itself may stay hidden. There is a lesson here about headlines, too. A sharp headline says a SpaceX rocket will hit the moon and leaves the rest out. The full story is more complex. One launch, multiple missions, a spent upper stage, months of tracking, and a final path shaped by gravity and sunlight. The better you understand the details, the less this sounds like a stunt, and the more it sounds like a warning. Warnings are valuable when they arrive early. Right now, the number of objects moving through cislunar space is still small enough for lessons to matter. If the world waits until traffic is heavy, cleanup is costly, and close calls are common, every fix becomes harder. This impact is small in force compared with the history of the moon, but it may be large in the timing of the lesson. And one last fact matters here. The moon keeps records longer than our news cycles. After headlines fade, the crater will still speak for us. What should matter more in the next space age? Speed or responsibility? Put your answer in the comments, subscribe, and turn on notifications if you want more true space mysteries, and share this story. Send it to someone who still thinks space is empty, simple, and far removed from human choices, because it is not simple anymore. A 5-story stage from a Falcon 9, weighing about 4,900 kilograms and racing near 2.43 kilometers per second, is about to prove that. Near the crater Einstein, close to the lunar edge, a machine built to begin a mission is ending as an accidental impact experiment. The crash itself may be brief, but the lesson behind it could last much longer. The next time you look at the moon, remember that it is no longer only a symbol. It is becoming a place where our skill, our ambition, and our carelessness all leave marks. What happens there will help define what kind of species we are when the frontier stops being distant and starts being busy. And sometimes that truth arrives not with a giant explosion, but with one silent piece of drifting metal. If you want more stories like this, subscribe, turn on notifications, and stay curious with me. Then tell me one thing in the comments. Should lunar missions be required to plan the final path of every major leftover stage? And if this story changed how you see the moon, share it with one person who needs to hear it. Thanks for watching. Thanks for thinking about the parts of spaceflight people usually ignore, and until next time, keep looking up.